Hello class, happy week 5. Sorry I didn't get this video out sooner today, nor did I do one last week, but hopefully last week's helpful homework file came through for you. I've sent another one for this week. So this week we're still tapping into the concept around the normal distribution. With that term, you should really have to think of other terms like z-scores and z-tables. Hint, hint. On this week's homework, questions 2, 3, and 4 have some calculations associated with them, and I've provided you some templates for you to just plug in the numbers, and make sure you click on the cells to see the formulas associated with them. We're also getting concepts around sampling introduced. Granted, we have these things called a population, which is kind of like the whole universe of things or people or units or whatever we're interested in studying. But we can never garner enough information about that whole population, hence we need to take a sample, kind of a subset of it to draw from, and we want that sample to be as representative as possible of the population. There's a couple techniques, 3 to be specific, that we can use to make our generalizations about that population from our sample as reliable and valid as possible. So one of those techniques is stratified or stratum-based sampling. That's basically when each person belongs only to one group. Then we have cluster or cluster-based sampling, where each person belongs to only one unit. And then we have the concept of the population, which is the whole group of units, whether it's persons, objects, other items, from which the sample is drawn. So there's 3 concepts, hint, hint, you should be able to match up perfectly. Some other concepts or things you should be aware of. You cannot eliminate sampling error by selecting an unbiased sample. And there's some things, every sample is going to be biased in some degree, but that's where we can do things like randomize. So randomization is key. Really just helps to ensure the representativeness, it's a long word, of your population. So contrary to cluster and stratified sampling, where you're deliberately trying to minimize the bias in your sample, randomization is like the really only other way to rely on matching the characteristics of your population to your sample. You're basically kind of letting chance do the work for you, and believe it or not, it works. That's the whole concept underlying the normal distribution. It's real. It's almost religious and biblical, in my opinion, because I've seen it so many times in so many studies that if you truly do randomize whatever you're sampling from, whatever population, it kind of balances everything out. And then when you start to see skews in your samples, whether they're tight or flat or bimodal, typically randomization was not occurring prior to the study. So. A couple other things. The sampling distribution around the mean becomes approximately normally distributed when your sample size is large. Hint, hint. And that's kind of should be intuitive. So the bigger the sample you have, the more representative of your population it is. And then we have this concept underlying what's called the 68, 95, 99.7 rule. So what does that mean? So these are percentages. So for z-scores, you have the mean of your distribution, and you have 1 standard deviation on each side, negative and positive, 2 standard deviations, negative and positive, and 3 standard deviations, negative and positive. Those first 2, positive and negative standard deviations, that refers to the 68. So 68% of the z-scores associated with a normal standard distribution are plus or minus 1 standard deviation. So that's 34 and 34 on each side. You move out 2 standard deviations on each side, so that's 95% of the standard deviations or z-scores are associated on the normal curve. And so you can split that in half, so it moves you out 47.5 and 47.5. And the third standard deviation, plus or minus, that's where 99.7 of your standard deviations or z-scores are accounted for in the normal distribution. So there's one question at the end there that's asking you to do some math where it's combining like 2 standard deviations to the right and 1 to the left. You just need to know to split the 68, the 95, or the 99.7 to come up the correct. It's just an addition problem. So that is that. Any other questions, feel free to email me. A couple of you have. Pretty much everything I've covered in this announcement and between the template should put you in very good graces of the automatic grading in the UMUX system for this 5th homework assignment. So that is all. Let's have a great week, and I'll talk to you later.